Welcome back, class. Thank you for joining me. So we are going to jump back into chapter 10. And today our focus is on section 2A. Now, before we jump into this, because this is our final chapter, at the beginning of every note, I'm going to do a little bit of review for finals to kind of help you guys get thinking and in that mindset because they are coming up fast. So, question number 1. To simplify when we are adding or subtracting polynomial expressions. Well, basically adding and subtracting both involve simply combining like terms. Now, I want you to remember though, when you're subtracting, we do something even more special. Subtracting, we turn it into an addition problem by switching the sign of everything in that second parenthesis, because then it's a lot easier to see what's actually happening, to remember that that negative is influencing everything in that second parenthesis. And now it's simply combining like terms. X cubed and 3x cubed add to be 4x cubed, noting that the exponent is not changing. Negative 2x and 4x, well, negative 2 plus 4 is a positive 2x. Then that is our only x squared. Then 1 plus 1 gives us 2. Now, the last piece to remember is when we're writing these out, we commonly like it in standard form. So I'm just going to switch these two really quickly so it can be actually written in full standard form. All right, and then number 2, that equation underneath it, x squared minus 4x minus 1 is called a quadratic equation. And remember, its graph is called a parabola. All right, so there we have that information, that little bit of review. Now, let's jump into our new material. So we're going to revisit this idea of simplifying radicals. So let's fit the first 15 perfect squares and their roots. So right now we are upping our game. All right, because we need to know all of these numbers. So I'm listing out all the perfect squares, and then after it, I'm listing what number made them, what their square root is. All right, so there are all of our perfect squares from 1 to 15. All right, so, and remember, those are the numbers we use in order to simplify these expressions. Now, what is a radical expression? Well, all that means is an expression with a square root. That's all that it really means. Now, what does it mean to simplify a radical expression? Now, that means pull out the largest perfect square That's where we started this whole adventure. And then the second piece to that is no radicals in the denominator. And remember, to fix that, that's a process we called rationalizing the denominator. All right, so now just to make sure that we know what we're talking about, here's a list of some expressions, and we want to know which ones are simplified, which ones are not simplified. So 5 square roots of 3, this first one. Well, looking at it, there's no perfect square that divides out of 3, and there's no radical in the denominator. So this one is simplified. That one's already good to go. 6 square roots of x. Well, no perfect square pulls out of x, because remember, for a variable to be a perfect square, that means that it actually has an even exponent. And there's no radical in the denominator, so this one is simplified as well. Getting to our next one, 5 over square root of 7. This one is not simplified. And the reason for that is that square root of 7. There's a radical in the denominator. So that one would not be considered a simplified radical expression. Then 3 square roots of 20. Looking at that one, also not a simplified expression because a perfect square can be pulled out of the 20. So that would indicate to us that those two bottom expressions are not fully simplified. All right, so moving right along. Let's review how we actually do simplify these things. So we need to be pulling out the largest perfect square in each of these. So the square root of 160. Now, this is why I had you remake your list to refamiliarize yourself with those first 15 perfect squares. So looking at our list, we need to see which is the largest one that divides 160. So looking at our list, the first number you got to was 4. And you're right, 4 definitely does divide 160. However, there's actually a bigger one, a better one. We can pull out a 16 from that 160. And so now, when we square root the 16, we get 4. So its simplified version would be 4 square roots of 10. The biggest thing of remembering to pull out the largest one. Now, same story for the 72. As you're looking, you will probably see that 4 divides 72. And then you'll come across and see that 9 divides 72. But if you're going for the biggest, you're going for the largest perfect square that divides it, you're going to want to pull out the 36. So again, make sure you don't just stop at the first number that you come to. You really have to make sure that you are encompassing the largest square root. And so that would be 6 square roots of 2. All right. Now let's take a look at some variables. So we've already talked about x squared, okay? So x squared, we've already talked about how that is simply x. All right, now we need to have a conversation though. What happens when you have even bigger powers? So x cubed. Well, what I want you to consider, x cubed is really x squared times x, correct? So what we want to do, we want to break it apart into groups of x squareds. All right, so in this case, we can separate it into x squared and x to the first, because 2 plus 1 gives us the 3. And then what happens? Well, what happens is that x squared piece can come outside of the radical as an x. But then the square root of x can't do anything. So you can pull out that x squared piece. However, the other x actually has to stay. So let's look at our next one, x to the 4. Well, x to the 4, if we're breaking it down into groups of x squared, is x squared times x squared. Now, notice what happens for this one. So x squared, so that comes out as an x. That comes out as an x. Well, what is x times x? Well, x times x gives you x squared. So for x to the 4, it actually pulls out completely and nicely. All right, well, let's look at x to the 5. X to the 5, if we're breaking it down into as many 2's as possible, well, x squared, x to the first. 2 plus 2 plus 1 gives us that 5. All right, so we have the two x's that come out again. Each x squared just comes out as an x. Well, and then we have that last one, that last x that does not have a squared on it, so it cannot pull out. So on the other side, the x times x still gives us x squared, but now we have that additional x that's still left inside the square root that we have to leave there. And then finally, let's take a look at this last one. So to get 6, x squared, x squared, x squared. So looking at that, I have this x squared that pulls out as an x, this x squared that pulls out as an x, and that x squared that pulls out as an x. So this time, when we're pulling out everything possible, x times x times x gives us an x cubed. Okay, so the question, is there a pattern? Well, I think there's definitely a pattern to this. Now, I'm not going to say the pattern right offhand. All right? What I'm going to do is I'm going to let you ponder about it. I want you to think about it a little bit. And then when we get back in class, we'll talk about what that pattern is really doing, what that pattern really means. But for now, let's do a couple of examples. So, 75. Well, square root of 75, we've already said, can break up into 25 and then 3. Okay, you want to pull out the perfect square. Well, that x cubed, we want to break it up into as many groups of 2 as possible. So remember, x cubed breaks up into x squared and x. So what's happening here? Well, we have 3 times 5, because square root of 25 becomes 5. We have that x squared piece that pulls out. But then we have the 3 and the x that are still stuck inside. Now, to make the outside look a little bit cleaner, 3 times 5 gives us 15. So on the outside, we have 15x. And on the inside, we have 3x. And that is what we're going to consider our simplified expression. All right, looking at our next one. So, 80. Now, this is another one of those potentially tricky ones. So 80, you may see that 4 divides 80, But if your goal is to get the largest one possible, you're actually going to want to divide 80 by 16 and get 5. So when we're looking at simplifying this, I'm going to break up that 80 into 16 and 5. And now I need to deal with my variables. So x to the 5 is x squared times x squared times x. 2 plus 2 plus 1 gives us that 5. And y to the 6 is y squared, y squared, y squared. 2 plus 2 plus 2 gives us 6. And now I'm going to start simplifying this. So I have negative 4 because of that square root of 16. Now for my x's, that x squared pulls out as an x. That x squared pulls out as an x. That y squared pulls out as a y. That y squared pulls out as a y. And that y squared pulls out as a y. And what do we have left inside the radical? Well, I see a 5 and an x that are going to end up being left inside the radical that can't be pulled out. So to write this a little bit more cleanly, x times x gives us x squared. Y times y times y gives us y to the cubed. And then what do we have left inside? Well, we have that 5x that couldn't come out. And that's going to be our reduced expression, our simplified rational expression. So please bear with me for one more page. All of this is building to multiplying. Okay? Now, with multiplying, there's some very important things to know. So how to simplify when multiplying. Step 1, multiply the outside. Two, multiply the inside. 3, simplify the inside. All right, so what do I mean by that? Well, by multiplying the outside, I'm talking about outside of the radical. So I mean, take that 2 times 3 and get 6. All right? When I say multiply the inside, I mean multiply inside the radical because that is what also combines. So 7 times 14 gives us a 98. T times t squared, 1 plus 2, gives us a t cubed. So that's the first 2 steps. Multiply the inside and then multiply the outside. Now, the third step, what's left is simplifying what is on the inside. So to simplify this, we have to see what perfect square pulls out of 98. Well, hopefully you can see that it is going to be a 49. 98 is 49 times 2. T cubed is going to be t squared and t. Remember, we're going to break up the variable. So now looking at this, I have 6, and then square root of 49 is 7. And then I can pull out that t squared as a t to be outside of my radical. And then what's left inside is just a 2 and the other t. All right, and now to multiply the 6 and the 7, so we get 42t on the outside, and then left on the inside again is just 2t. And that is what we're going to consider our simplified expression. All right, moving right along. So, our next one. First step, multiply the outsides. So 2 times -1, remember there's just a negative there, consider it to be a -1. So 2 times -1 gives us a -2. Then on the inside, a and 9a cubed. So we have 9, and then a times a cubed, 1 plus 3, gives us an a to the 4. All right, now, the cool thing about this is 9 is already a perfect square. And then a to the 4 breaks up into a squared and a squared. So we get -2. Square root of 9 becomes 3. Then this a squared comes out as an a. That a squared comes out as an a. And this time there's actually nothing left inside of the radical. Everything actually pulls out. So what are we left with? Well, -2 times 3 is a -6. A times a is an a squared. And one last example for us before we're done with our video. Multiply the outsides. 7 times 3 gives us 21. Multiplying the insides, 5x and 20x to the 5. Well, 5 times 20 is 100. X times x to the 5 gives us x to the 6. Now 100 is already a perfect square. Then x to the 6, we can break up into x squared, and x squared. So we get 21. Square root of 100 is 10. And then each of these x squareds comes out as an x. So in this one, in the end, we have 210, and then x times x times x gives us x cubed. All right, so thank you so much for joining me. I realize this got to be a long video, and I apologize for that. But please make sure you have everything written down, and then we will do our practicing in class.